Question number 11. Electric potential of two conducting parallel plates are minus 10 volts and 30 volts respectively. If the separation between the plates is 2 centimeters, what is the electric field intensity between the plates? So there are two parallel plates like this, which are connected to an external power source, and here if this is the positive charge plate and this is the negative charge plate, an electric field will be created in between these two plates like this, and let the electric field intensity of this field be E. So if the potential here is V2 and potential here is V1, so V2 is greater than V1, so you can, if the separation is simple D, so you can write the electric field intensity E is equal to the potential difference V2 minus V1 divided by the separation D. So this is an equation that you should know, and if you just do the calculation, you will get E is equal to 30 minus 10 divided by the separation here is 2 centimeters, so that is 0.02 meters. So if you just simplify this one, you will get the answer as 2000 volts per meter. So the answer is answer number 3. Question number 12. Which of the following is not true about the electric field lines? So electric field lines are imaginary lines which are used to represent the pattern of an electric field. So that definition is given as the fifth answer, so that is correct. So let's move through the stems. Field lines start from positive charges and end at negative charges. That is true. So by convention, field lines are drawn starting from positive charges and they are reaching the negative charges. So if you have two charges, a positive charge and a negative charge like this, so the field lines are moving like this. So they are moving away from the positive charges and lines are moving towards the negative charges. So this is basically because these field lines, they are defined as the pathways of unit positive charges. So you know, positive charges, they are repelled by positive charges and attracted by negative charges. So that is why the direction of the field lines is like this. So answer number 3, two field lines can never cross each other. That is also true. There is, if a single positive charge exists, field lines end at infinity. That is also true, because if you consider a single positive charge isolated like this, so field lines are starting from the positive charge and they may tend to go towards infinity like this. So if you consider an isolated negative charge, field lines are coming from infinity and reaching it like this. So that statement is also correct. Then electrostatic field lines form closed loops. This is false. Magnetic field lines can form closed loops, but electrostatic field lines can never form closed loops. So that should be the answer. Question number 13. The sound source of intensity I1 produces a sound intensity level of 90 decibels at a certain point. Another sound source of intensity I2 produces a sound intensity level of 40 decibels at the same point. The distance from both the sources to the point is the same. What is the ratio of I1 over I2? So this question is related to sound intensity level. So sound intensity level beta is equal to 10 log 10 to the power I over I naught. Here I is the intensity at a specific point, I naught is the reference intensity, so which is a constant. So here you can write beta here you can write first one 90, so 90 decibels, that is equal to 10 times log 10 to the power I1 over I0. Then at the same point another sound source of intensity I2 produces intensity level of 40 decibels, so you can write 40 is equal to 10 log 10 to the power I2 over I0. So here what you can do is you can so this is equation number 1 and this is equation number 2, so you can just subtract equation number 2 from equation number 1. So here you can write if you simplify, this 0 and 0 cancels and this 0 and this 0 cancels, so you can write 9 minus 4 is equal to log 10 to the power I1 over I0 minus log 10 to the power I2 over I0. So I just skip the simplification steps, so you can write 5 is equal to just by simplifying these logarithms you get an answer like this, log 10 to the power I1 over I2. So you can get the anti-logarithm of this to find the ratio I1 over I2, which will be equal to 10 to the power 5. So that will be the answer number 5. Number 14, the photoelectric threshold frequency of a metal is F0 when light of frequency 4 F0 is incident on the metal. What is the maximum kinetic energy of the ejected photoelectrons? So the equation that we can use here is the maximum kinetic energy K is equal to H F minus F0. Here F is the frequency of the incident light and F0 is the threshold frequency. So you can directly apply the values for this equation, so that H is equal to 4F0 minus F0. So you can write the maximum kinetic energy of the ejected photoelectrons is 3HF0. Right. Question number 15. A convex lens of focal length 20 centimeters and a concave lens of focal length 5 centimeters are kept along the same axis with the distance simple d between them. If a parallel monochromatic beam of light incident on the convex lens leaves the concave lens as a parallel beam, what is the distance simple d? So this question is there in several papers from this international level papers. So I actually downloaded this from the internet. Same question is there in the internet. So you can see there are two lenses. The first one is a convex lens and the second one is the concave lens, and here parallel rays are coming towards this convex lens, and after refracting from this, convex lenses are converging lenses, so this light rays should converge, so they should move towards the axis, principal axis. So if you consider the emerging rays from this concave lens, they are also parallel. So what is the necessity in order to get this refracted rays from a concave lens to be parallel? The necessity is the object should be placed at the focus of this lens, of this concave lens, and that object is actually virtual object. That means here if you consider that two foci are there for this concave lens, let's say one focus is here and the other focus is at somewhere here. So if the object is formed here, then so let's in order for the object to be at the focus here in the right side, the incoming rays should point like this, so towards the focus. So the images are not drawn to scale. The actual ray diagram for this is this, so like this. So here there is the convex lens, so parallel rays are coming which are converging towards the concave lens, and here you can see if you just extend these converging rays, they will form a virtual a real image here if the concave lens is not there, but this image formed by this convex lens acts as the object for this concave lens. Image formed here, image formed by this, the real image formed by this convex lens acts as the virtual object for this concave lens. So that virtual object is at the focus of this concave lens. Therefore the emerging rays should be parallel to the principal axis. So just by looking at this image you can see the distance between these two lenses should be 20 minus 5, which is 15 centimeters. So you can do a calculation as well to get the same result. For that you need to apply the lens formula to both the lenses. So if you consider the convex lens, here the object distance is u is equals, the object should be placed at infinity in order to get parallel rays like this. So the object distance is infinite and the image is formed at the focal length, so the image distance is, so if you consider the new Cartesian sign convention, it should be negative 20 centimeters. So you know focal length f of a convex lens is assigned as negative, so according to new Cartesian sign convention, so that is also negative 20. So you can just apply the lens formula 1 minus v minus 1 minus u is equal to 1 minus f. So here actually we don't know here where the image is formed, so we don't know this, so you need to find v. So if you just apply substitute the values for this, you can write 1 minus v is equal to minus 1 over 20 plus 1 over infinity. So you get the answer for v as v is equal to minus 20 centimeters. Right, so you can see the image is formed 20 centimeters from the convex lens. Then you can apply the same equation for this concave lens. So you know the focal length of a concave lens is assigned positive, so f is equal to positive 5 plus 5. So here the necessity is the object should be a virtual object which it should lie at the focus of this concave lens. So what we need to find here is if the necessity is like that, so the emerging rays should be parallel. So if the emerging rays are parallel, the image will be formed at infinity. So image distance will be v is equal to, here according to new Cartesian sign convention, that is negative infinity. So you can just find the object distance u by applying the Lenz's formula, 1 minus v minus 1 over u is equal to 1 over f. So you can just bring this and you can write 1 over u is equal to 1 over v, that is 1 over negative 1 over infinity. Then here this becomes negative 1 over 5. So you can write u is equal to negative 5 centimeters. So you get the same result as it derived from by just drawing this image. So in order for this to happen, the necessity is simple d should be equal to 20 minus 5, which is 15 centimeters, right? Question number 16. Trolley X of mass m and trolley Y of mass capital M are moving in the same direction along a straight line on a smooth horizontal surface. The speed of trolley X is twice that of trolley Y. So if you consider two trolleys X and Y, the mass of X is simple m, mass of Y is capital M. So they are moving in the same direction along a straight line, and the speed of trolley X is twice as that of trolley Y. So if the speed of trolley Y is v, speed of X is 2v. When the two trolleys collide, both move together with a common velocity. That means when a collision happens between these two trolleys, so if you consider this is trolley X and this is trolley Y. So if these two are colliding, that is this, you can see that this trolley X is approaching trolley Y as the velocity here is greater. So when a collision happens between these two, they tend to move with the same final velocity. So the question is not saying that they are just attaching each other after the collision, they are just moving as separate trolleys after the collision but with the same velocity. So let's consider that common velocity as v dash. So due to the collision, if the speed of trolley Y is increased by 20%, what will be the ratio of capital M over simple m? So they are saying that trolley Y, the velocity has increased by 20%. So the initial velocity is v, 20% increase means this v should be increased by 0.2 plus v, this 0.2 v should be added to this v, which is equal to 1.2 v, or you can write 12 over 10 or just 6 over 5 v. So this will be the final velocity of trolley Y. So in the previous statement they are saying when the two trolleys collide, both move together with a common velocity. So both are moving with this velocity. So v dash is equal to 6 over 5 v. Right. So they are asking what will be the ratio of capital M over simple m. So how can we find this? So you can just apply. So during a collision, there are no external forces acting upon this system, as the surface is smooth, so there is no frictional forces as well. So you can apply the law of conservation of linear momentum. So the initial momentum of the system in the given direction is equal to the final momentum of the system in that same direction. So you can write the initial momentum is equal to a simple m times 2v plus capital M times v. So that is equal to the final momentum, which is simple m times v dash, which is 6/5 mv plus 6/5 capital M v. So the term v is there in all the terms, so you can just cancel this v and you get 2m plus capital M is equal to 6/5 m plus m. And just simplify this and you will get an answer like this: 10 simple M plus 5 capital M is equal to 6 simple M plus 6 capital M. So you can just exchange the terms and get the answer. You get 4 simple M is equal to capital M. So the ratio, they are asking the ratio M over M, capital M over simple M, which will be equal to 4. Right. Question number 17. A ball is projected upwards at an angle of 60 degrees with the horizontal. If the initial kinetic energy of projection is K, what will be the kinetic energy of the ball at its maximum height? Neglect air resistance. So this is with regard to a projectile. So that projectile is projected upwards at an angle of 60 degrees with the horizontal. So if the horizontal is like this, so let's consider that horizontal is like this and it's projected at an angle of 60 degrees, and it will show a projectile motion like this. So here is the point of the projection, and here it is the maximum point at which the height is maximum. So at the maximum height, so you can just divide, or you can just consider two components of this initial velocity. There is a vertical component and the horizontal component, and this horizontal component is constant throughout the motion because there is no acceleration along the horizontal direction, but there is the acceleration due to gravity in the upwards direction. So the upward component, initially the velocity will reduce, and at the highest point the vertical component becomes 0, and it will again gradually increase when coming down. So let's say that the initial velocity here is v, or the initial speed is v. So you can just get the horizontal component, which is equal to v cos 60. Cos 60 is half, so the horizontal component is v over 2, which is constant throughout the motion. So when calculating the kinetic energy, we are considering the speed, not the velocity. So you can see initial kinetic energy K is equal to half times mv squared. So let's say that the kinetic energy at the maximum point is K dash, so that is equal to half times, the mass is constant. Here the velocity is there is no vertical component, only the horizontal component is there, which is equal to v over 2. So you can get v over 2 square. So by simplifying this, you get K dash, I am not doing the simplification, K dash should be equal to K over 4. So you can just by intuition you can see that when the velocity or speed is halved, the square should be v over 4. So kinetic energy should be reduced by a factor of 4. So the answer is answer number 4. Question number 18. An immersion heater made of a wire of length L and distance d takes 4 minutes to raise the temperature of a given mass of water by 40 degrees Celsius. how much time is taken for heating a same amount of water by 40 degrees of Celsius using another immersion heater made of a wire with the same material but having length 2L and diameter 2D. Neglect heat loss to the surroundings. So how can you just find the time taken? So they are asking how much time is taken for heating same amount of water by 40 degrees, same amount of water by the same up to same temperature. This temperature difference is same. So what is the difference here? The difference is between the wire of this immersion heater. So here in the first instance the length of the wire is L and the diameter is D, whereas in the second instance the length is doubled and the diameter is also double. So what varies when you change the length and the diameter? So the resistance of this wire will change. So you know resistance R is equal to resistivity rho times L over A, length over diameter, length over area, cross sectional area. So rho is same as both the wires are made up of the same material. So length and the cross sectional area is changed. So here if the resistance of this wire is R, and let's say here the resistance is R dash, so you can write R is equal to rho L over A and R dash is equal to rho 2L over, here you can write R is equal to rho L over A is equal to phi R squared, which is phi D over 2 squared. Here it is phi 2D over 2 square. So if you just do the simplification, we can just get an answer. So you can write R dash over R is equal to here it is rho 2L over pi D squared, here rho L over pi D squared over 4. So you can simplify this expression and get an answer for R dash as R times so here half of R over 2, R divided by 2. So the resistance of the wire is halved. So when the resistance is halved, what will happen to the time taken for this process to happen? So here you can consider the power generated by this immersion heater. So power is equal to P is equal to VI, or you can write it using the resistance as V squared over R. So power means the amount of energy which is used or which is generated per unit time. So power is equal to energy over time. So the V square, V means the potential difference or the voltage. So the voltage is actually dependent upon the main power supply, so that should be constant. So you can write so power is energy over time. So amount of heat energy generated from this, H is equal to power times time, which is V squared over R into T. So here they are saying we need to heat up the same amount of water by 40 degree Celsius. So the heat needed for both the processes should be the same. So you can see from that this relation that if this is constant, this is also constant. You can see that the resistance R is proportional to the time taken for that process to happen. So here the resistance is halved. Initial resistance is R and the final resistance R dash is R over 2. So if the resistance is halved, the time taken should also be halved. So when the resistance is halved, time taken also should be halved. So the time taken for the first process is 4 minutes. Here it should take only 2 minutes. Question number 19. Assume that the Earth revolves around the Sun in a circular path of radius r1 with a speed of v1, and Mars revolves around the Sun in a circular path of radius r2 with a speed of v2. What is the ratio of v1 over v2? So this is regarding planetary motion. There are planets moving around the Sun. So you can say the orbit is actually elliptical, but here they are saying the orbit is circular. That's all right. So you consider this is if this is Sun and if this is a planet. So if the radius of this path is r, so what is the necessity for this circular motion is there should be a centripetal force. That centripetal force is supplied by the force of gravity. So you can write the equation for centripetal force is mv squared over r. So here the mass of the Sun I am taking as capital M, and mass of the planet I am taking as simple m. So this centripetal force is supplied by the force of gravity, which is given by the Newton's universal law of gravitation, G capital M simple M over r square. So by simplifying this equation, you can see the velocity will be equal to square root g m over r. So you can see this g and capital M are constants. So if you consider two planets v1 and with velocities v1 and v2 and the radii of the paths r1 and r2, you can just consider this velocity is inversely proportional to the root r. So v1 over v2 should be equal to the square root r2 over r1. The answer will be number 3. Question number 20. Variation of linear magnification of real images formed by a convex lens with the image distance v is best represented by. So this is a bit tricky question. They are asking the linear magnification of real images formed by a convex lens with the image distance v. So the two axes, if you consider the two axes here, y-axis represents linear magnification and x-axis represents the image distance. So you know the equation for linear magnification. Linear magnification is equal to the ratio between the image distance and the object distance, v over u. And if you just apply the lens formula for this scenario, so they are asking real images formed by a convex lens. So if there is a convex lens like this and light is coming from this direction and moving towards the right side, so object will be placed towards the left of the lens here, that is the object. So real images, they are formed in the left side. So they are actually inverted images. So image is formed in the left side. So according to new Cartesian sign convention, the object distance is taken as u, which will take a positive value, whereas the image distance is taken as v. As the image is real, we can assign a negative sign here, and let's say that the focal length of this length is f. As this is a convex lens, according to the sign convention, takes a negative sign. So here you can apply the lens formula 1 over v minus 1 over u is equal to 1 over f. So here it is 1 minus 1 over v minus 1 over u is equal to minus 1 over f. You can multiply both sides of the equation by v. So you will get minus v over v minus v over u is equal to minus v over f. So here it becomes minus 1 minus, so v over u is the linear magnification, is equal to minus v over f. So you can just rearrange this equation and write simple m is equal to v over f minus 1. So this equation is in the form of y equals mx plus c. So here this equation is in the form of let's say m is equal to v over f minus 1. So this is represented by the y-axis. This is equal to, so x-axis they have taken the image distance, which is v. So you can write 1 over f times v for this. This 1 over f is the gradient. So here you can write this equation as m is equal to 1 over f v minus 1. So this is y equals mx plus c type equation, but here the intercept is minus 1. So if you draw a graph for the y-intercept to be minus 1, it should be like here negative. So the graph should start from here, and the x-axis is v and the y-axis is linear magnification. So this should be a linear graph like this. So this negative part is not drawn here. So out of the answers, the most suitable answer is answer number 2. So you can just get the answer from this derivation. Question number 21. If a proton is projected with a velocity v along the axis of a current carrying long solenoid, what will happen for the proton? So here a solenoid is thin like this, so there is a coiled wire, and if a proton or if any charge mass or any charged object is projected with a given velocity, specific velocity, the velocity is along the axis of the current carrying solenoid, that is it's like this, velocity is along the axis of this solenoid. So this solenoid can generate a magnetic field. So the field lines will look like this. So field lines will be like this. So here, as the proton is just projected parallel to this axis, there will be no perpendicular component of this velocity to the lines of this magnetic field. So as there is no perpendicular component, it's not cutting the magnetic field lines. That means a force will not be acted upon this charged particle or the proton. Is same for a negatively charged particle like an electron as well. So force on this proton is given by F is equal to BVQ sin theta. So here B is the intensity of this or the magnetic field, the magnitude of the magnetic field, and here V is the velocity of the charged particle and Q is the charge. And here, as this is parallel, the sin theta component, sin theta will be 0 and sin theta will be 0, so there will be no force acting upon this. So the proton will continue to move with the same velocity v along the axis. So answer will be answer number 5. Question number 22. The figure shows a semicircular uniform thin sheet. The center of gravity of the sheet is most likely to be found at. So here they are asking the centroid of a semicircle. So to exactly find the location you need integral calculus, but this question you can just do by intuition. So here there is the semicircle. So you can see the circle is complete like this. The center of mass will be here at point A. But here this is a semicircle. So if you just consider a rectangle like this, the center of gravity should be at the center here. So you can see clearly that some parts of this rectangle are missing. So the center of gravity should move down because there is some loss of mass here from above. So the center of gravity should lie between these 2 points. So point C given here is at the center of this. If you consider the radius to be r, here point C is lying at distance r over 2. So you can clearly see that the center of gravity should lie between point A and point C. So the only answer given that is answer number 2, which is B. To find the exact location you need integral calculus, which is actually not in your syllabus. So you can just find the answer for this by intuition by this method. Question number 23. Two conducting circular loops A and B are kept on the same plane with a straight current carrying wire at either side of it as shown in the figure. If current I in the wire decreases in magnitude, the induced current in the loops. So there is a current carrying straight conductor in the middle of this and on either side of this there are two loops, wire loops. So what will happen when a current is going through this conductor? So according to this there will be a magnetic field created surrounding this current carrying wire, and it will go in loops like this. So if the wire is like this, so there will be a magnetic field created around this current carrying conductor, and the direction of the magnetic field is given by Maxwell's corkscrew rule. So this is it. So you can point the thumb along the direction of the current, and the other fingers will give the direction of the field. So here, applying this corkscrew rule, you can find that the direction of the magnetic field at loop A is outwards from the plane of the paper. So you can just mark it like this, the front of the arrow, and near loop B it will be into the paper, because here you can see this is towards this out of the paper, and in the other side it's the other way. So here it's into the paper. So what is happening to this magnetic field? So they are saying that the current I in the wire decreases in magnitude with time. So when current I is decreasing, the magnitude of these magnetic fields will also decrease with time. So there will be a changing magnetic field with regard to in relation to these wire loops. So if there is a changing magnetic field or the change of magnetic flux, according to Faraday's law, there would be an induced EMF, which in turn creates a current in these loops. So using Lenz's law, we can find the direction of this induced current. So Lenz's law states that if there is a change in the magnetic field related to a current carrying conductor, so always the induced EMF will generate a current, so that it will create another magnetic field that will oppose the change. So a magnetic field will be created by inducing an EMF which will oppose the change which was created here. So here you can see that the induced magnetic field direction is outwards from the paper. So using another law, another right hand rule, we can find the direction of the magnetic field which will be created by a current in a loop. So again you can take your right hand, and here you are pointing the four fingers in the direction of the induced direction of the current, then the thumb will point to the direction of the induced magnetic field. So here in loop A, so according to Lenz's law, you need to create a magnetic field. So the magnitude of the field is decreasing outwards from the paper. So a magnetic field should be created which is opposing that change. That means there should be a current, there should be a magnetic field created, again pointing outwards from the plane of the paper here. So in A, the current should flow in an anti-clockwise direction. Here in A, the current should flow in an anti-clockwise direction, and it's the other way around for B. So in B, the current should go in a clockwise direction. You can apply the same principle and find the In B, the current should be generated in an anti-clockwise direction. So it should be in B it will be clockwise. So the answer will be 2. In A it will be anti-clockwise and in B it will be clockwise. So I found the same question in this website as well. So you can actually these Sri Lankan aerial questions, most of them can be found in the internet, or at least a similar question can be found. So you can just search in the Google, or you can use these large language models, LLMs, such as GPT-4 or Bard, and type the question, and they most times they will generate the correct answer. Sometimes but the answer can be wrong, but most of these questions you can find in these websites, these Byju's, Docker, such websites. These questions are there. The question number 24. The figure shows a Ferris wheel rotating in the clockwise direction. A loudspeaker fixed at X emits continuous sound waves at a constant frequency f0. Consider the following statements regarding the pitch of the sound heard by a man in the Ferris wheel when he passes positions P, Q, R and S. So this question is from Doppler effect. So you can see when the observer is here at P, the instantaneous velocity of this observer is in this direction, towards right side. So according to the Doppler effect, the observed frequency will be higher here, and at the lowest point the velocity is towards the left, which is that means the observer is moving away from the source. So according to Doppler effect, the observed frequency will be lower at the lowest point. But at Q and S, you can see at Q it will be directed downwards. So the sound waves are coming like this. Sound waves, velocity of the sound waves are towards this direction. So at Q and at S, the velocity of the observer will be perpendicular to that of the sound waves, of the wavefronts of the sound waves. So at Q and S, as the observer's velocity is perpendicular, there would be no component of that velocity in the direction of the propagation of the wave. So at Q and S, the observer will hear the original frequency of the speaker. Here at P, the observer is actually reaching, he is moving towards the sound source, and at R he is moving away from the sound source. So if you just look at the statements, statement A says the original pitch is heard when the man is at position Q and S. So that is true, as the velocity is perpendicular to that of the sound. B, the highest pitch is heard when the man is at position P. So if you consider these 4 points, this is correct. Out of the points P, Q, R is that they have mentioned the highest pitch is heard when the man is at position P. But he will hear a higher pitch at a certain direction. If I just draw it, you can see, if you draw a straight line starting from this point source to the Ferris wheel, you can see that these wave fronts are moving in circular paths like this. So at a point here, at this point, the velocity of the observer will be in the direction of the velocity of the sound waves. So this is the point that he will hear the maximum frequency. Right. So there is a problem with this question. I am not sure whether they are asking the highest pitch when considering these 4 points. So same goes for statement C. The lowest pitch is heard when the man is at position R. That is true. when considering these 4 points. So the answer should be either answer number 1 or 5. The marking scheme is not released yet, so I need to check this with the marking scheme. Or maybe I might have made a mistake, so it's open to you what whether I have made a mistake or whether my reasoning is correct. Right, so let's move on to the next question. Question number 25. Consider the following statements regarding the magnitude of the magnetic force acting on a current carrying wire placed in a magnetic field. So the force on a current carrying wire which is kept in a magnetic field is given by F equals BIL sin theta. So you can see, so this is the magnetic force. It depends on the length of the wire, that is true. L is there, the length of the wire. It depends on the way the wire is bended, that is also true, because that determines this angle theta. It depends on the cross-sectional area of the wire. So there is no cross-sectional area here, so this should be false. So only A and B are true.